Okay, here in example 4, we're going to add in phase shift and vertical shift so we can get an idea of how those two things affect the graph. And so here we have y equals -4 sine x plus 2. And so just like I did in example 1 earlier, I'm going to start by finding the amplitude. And the amplitude is the number in front of sine or cosine. And so in this case, that's -4, but remember the amplitude is considered to be positive since it's a distance. And so I'm just going to put 4. But I am going to circle that negative because remember, that's going to change the order of my points. All of my maximums are going to become minimums, and my minimums will become maximums. Now, this problem has a vertical shift in it. It is given by this +2 that is outside of the parentheses here in this particular problem. So sometimes there's this ambiguity between functions, and so sometimes you're going to see this same function written like this, but if you don't see parentheses, the assumption is that the +2 is outside of the parentheses. If they wanted the +2 to be inside the parentheses, they would absolutely put parentheses. But because you don't see parentheses the way this problem is typed, you can assume that it means what I wrote here. So the vertical shift here is going to be up 2. And so what that tells me is that my midline is going to be at y is equal to 2. And so I'm going to draw a little dotted line, or dashed line if you will, and call that my midline at y equals 2. Now, if my amplitude is 4, that means the distance from that midline to my maximums has got to be 4. So my midline's at 2. To make the distance 4, that means my maximums are going to have to go up to 6. And my minimums are also going to have to be a distance of 4, which is that amplitude, from my midline, which is 2. And so the distance being 4 means that my minimums are going to have to occur at -2. That way you've got a distance of 4 on both sides of your vertical shift. Okay, so hopefully that part is making a little bit of sense. We're going to continue going here by finding our period, which is going to be 2 pi divided by b. In this particular problem, b is 1. That's the coefficient in front of x. And so 2 pi divided by 1 is going to give me 2 pi. That helps me find the x increment, which is going to be the period divided by 4. And 2 pi divided by 4 will reduce to pi over 2. And then finally the phase shift, which would be if there were a plus or a minus after the x in the parentheses. Well, if you look at this version here, notice that there is no plus or minus in those parentheses, and so therefore our phase shift is 0, and that tells me that my starting x value is also at 0. Now, starting at 0, counting by my x increment, that's going to give me pi over 2, and then 2 pi over 2, which will reduce to 1 pi, and then 3 pi over 2, and then finally 4 pi over 2, which again will reduce this time to 2 pi. Now, we are graphing a negative sign function, and a negative sign function begins with a quote-unquote 0, but it's not going to be a 0 this time, because now my zeros, quote-unquote, will happen at y equals to 2. And so I'm going to put my first point right there on my midline at x is equal to 0. X equals to 0 being here, and then going on my midline. So every 0 is going to occur here. Every maximum is going to occur here, and every minimum will occur down here. And so for my sine graph, my negative sine graph, the next point is going to be a minimum, and so that's going to be down here at -2, and then back to my midline, and then up to a maximum at 3 pi over 2 and 6, and then back to the midline at 2 pi and 2. And so the graph is going to come down here to this minimum first, curve back up, and then go back down to that last midline point. Okay, here on example B, we notice that for the first time we're going to have a phase shift because I've got a plus pi over 2 in here in the parentheses along with the x. And so We'll get there eventually. Let's start, as always, with that amplitude, which is the coefficient in front of cosine, which is just 1. And then my vertical shift is at the end of the function. That is also positive 1. And so that tells me that my midline is going to be here at y is equal to 1. So with an amplitude of 1, that means that my maxes are going to have to be at 2, and my minimums are going to have to be at 0 on that y-axis. Okay, so period. Period is going to be 2 pi divided by b. Well, in this case, b is just 1, and so 2 pi divided by 1 will be 2 pi. That will help me find the x increment, which is my period divided by 4, and so that will be pi divided by 2. That's going to tell me how to count on the x-axis. And then finally, the phase shift. First thing you would have to do is factor out the b, but since b is 1 in this problem, you don't have to factor anything out. You can just look at the plus pi over 2 here, and remember from our earlier discussion that the plus is actually going to make the graph go to the left pi over 2. And so my starting x value for the first time in these notes is not going to be 0, it is going to be negative pi over 2. Okay, once I have that, negative pi over 2, I'm going to start counting by my x increment here to get my other 4x values. So negative pi over 2 plus pi over 2, I can write that down just so that it's totally clear. That is going to cancel and give me 0. So that will be my second x value point. If I add another pi over 2, that's going to equal to pi over 2, which I'll put right here. And then finally, adding again, pi over 2 plus pi over 2 is going to be 2 pi over 2. When I put that on my graph, I'm going to reduce it to become pi. And then finally, plus one more pi over 2, that's going to give me 3 pi over 2. Okay, so we are now ready to graph a cosine function. Cosine functions begin with maximums. So here at negative pi over 2, that's my first x value, I'm going to plot a point where there should be a maximum, and so that's going to be up at 2. My next x value is here at 0. That's going to be a quote-unquote 0, but remember, zeros are occurring at y equals 1 now because everything got shifted up 1, and so I'm going to plot my point there at 0, 1. And then a minimum at pi over 2, a midline point at pi, and then finally another maximum at 3 pi over 2. And so we're going to have a graph that looks something like this. Okay, and so just one more time, that phase shift is always going to tell you what your starting x value is. And once you get that, you know that you're going to count by that x increment. Okay, here in letter C, I've got sine of 3 and then parentheses x plus pi over 3. And so my amplitude here is going to equal to 1. That's my coefficient in front of sine there, which is a 1. And then my vertical shift is any plus or minus at the end of the function, which in this case there's not 1, which means that my midline is going to occur at y is equal to 0. Therefore, my maximums have to be at positive 1, and my mins have to be at negative 1. Next, I want to find the period. So the period is going to be 2 pi divided by b. Well, in this case, the b has been factored out. That right there is my b, and so I'm going to have 2 pi over 3 be my period. The x increment there then is going to be the period 2 pi over 3 divided by 4. Well, this is where you have to be good at some 5th grade math, some fractions. What does it mean to divide by 4? It really means just to multiply by 1/4. Okay, well now if I can get that far, how do I multiply fractions? Well, I multiply across, and so the numerator is going to be 2 pi times 1. The denominator is going to be 3 times 4, which is 12, and then 2 divided by 12 is going to reduce to give me an x increment of pi over 6. Okay, and then finally, the phase shift. Okay, well, because that b was factored out, all I really need to do is look to the inside of the parentheses there remembering that the plus really means that I'm going to go to the left. And so negative pi over 3 is going to be my first x value. I'm going to leave a little bit of space for another x value. Just trust me, there's going to be another one on that left side, so go ahead and leave yourself some space right in this area for your second x value. Okay, to get that second x value, we start with the phase shift, which is negative pi over 3, and we add our x increment, which is pi over 6. Now, those two numbers cannot be added together because they don't have the same denominator. And so to get them to have the same denominator, this is going to have to be multiplied by 2 over 2. And so now they have the same denominator, and negative 2 pi plus 1 pi is going to give me negative 1 pi over 6. And so that's going to be my next x-coordinate, negative pi over 6. Now, things start to get easy from there, because if I add another x increment, that's going to give me 0. If I add another x increment, 0 plus pi over 6 is going to give me pi over 6. That's my fourth point. And then one more x increment of pi over 6 is going to give me 2 pi over 6, which of course will reduce to 1 pi over 3. Okay, now that we've got our 5x values, we've got our 3y values, we're ready to graph the order of the points for a positive sign graph. And so a positive sign graph starts at a 0. I am actually going to graph a 0 here, meaning on the x-axis, since we didn't have a vertical shift. So there's my first point. I'm then going to go to a maximum at negative pi over 6, back to a 0 at 0, a min at pi over 6, and a 0 at pi over 3. And so here is my graph of this particular function right there. Okay, here in example D, we see that we are going to have an amplitude given by 1/2, which is that number in front of the cosine, a vertical shift of 0, since there's no plus or minus at the end. And so my midline is going to be at y equals 0. My amplitude is 1/2, so that means the distance there is going to have to be 1/2, and the distance here is going to have to be 1/2, which we'll put that down at negative 1/2. Okay, next thing would be the period. The period is going to be 2 pi divided by b, which in this case has been factored out. So 2 pi divided by 4 is going to reduce to pi over 2. The reason that's helpful is so that I can find that x increment. So pi over 2 and then divided by 4, which again, just remember, is the same thing as the multiplying by 1 over 4, and then multiply across to get pi over 8. Finally, the phase shift. The phase shift is given by what's on the inside of the parentheses, as long as that b is already factored out, which it is. And so therefore, the phase shift is going to be to the right, pi over 4. And I just put positive pi over 4 to indicate that we're going to start to the right of the y-axis. And so that pi over 4 is my first x-axis point. To get to the next x-axis point, I start with that and I add my x increment. And so just like before, I'm going to have the same denominator in order to add these fractions, which means I need to multiply this one by a 2 over a 2. And so that's going to give me 2 pi plus 1 pi, which is 3 pi divided by 8. And so that'll be my second x value. My next one will be adding another pi over 8, which will get me to 4 pi over 8. So I'll just go ahead and write that down. You can write down as much of this as you think you need to. What you cannot do is use a calculator. So you are going to have to be able to do this mental math in your head. 4 pi over 8 will reduce to pi over 2. And then plus another pi over 8 will give me 5 pi over 8. That will be my fourth x value. And then finally, one more pi over 8 is going to give me 6 pi over 8, which I know will reduce to 3 pi over 4. Okay, looking back to the function now, this is a cosine graph. More importantly, it is a positive cosine graph. Make sure that you actually put a point where your first x value is. Don't graph anything over here on this example because this was not an x value. So at pi over 4, we're going to graph a maximum since cosines begin at maximums. and then go to a 0, and then a min at pi over 2, another 0 at 5 pi over 8, and finally finishing off with a maximum and drawing our graph going through those points. Okay, so you may have noticed on the last two examples that finding the phase shift was pretty easy because the b, or the number in front of x, had already been factored out of the expression, but that's not always necessarily the case. And so when the inside of the function is of the form bx minus c, meaning that the b has not been factored out, there are two ways to determine the phase shift. And which one you choose is completely up to you. I will not really care which one you utilize, but here are the different ways that you can do this. You can factor out the b. And I sort of showed this earlier when we first introduced phase shifts, because if you have bx minus c and you just sort of like force factor out that b, then what you get is x minus c divided by b. So that is one scenario, one possibility for how you could find the phase shift. The phase shift would then be c divided by b. Now, the other option is that you could set bx minus c equal to 0 and then solve for x. And sometimes that's easier. Some people don't really like solving for x, especially when fractions are involved. Some people think that factoring out is easier, but I will give you the choice. You can do whatever you want. So here, if we solve this equation, we're going to add c to the other side and then divide by b. So x is going to equal to c divided by b. That will also give you your phase shift. And so I'm just going to work an example, and I'll do it both ways. Let's just say that your parentheses said 2x plus pi over 6. If I use method 1, then I need to factor out a 2. And so that's going to leave me with 2 times x plus pi over 6 divided by 2. Well, dividing by 2 is really just multiplying by a half. And so if I multiply this number by 1/2, that's going to end up giving me pi over 12. And so I can see here that from this, the phase shift is going to be negative pi over 12. The second option is to take my parentheses, 2x plus pi over 6, and set it equal to 0, and then solve for x. And essentially, you end up doing the exact same thing. So this is going to be 2x is equal to negative pi over 6. Divide both sides by 2, and so x is going to equal to negative pi over 6. Dividing by 2 is the same thing as multiplying by a half, and so you see that you end up getting the same phase shift right there. So your choice, you can either factor out the b, set bx minus c equal to 0, and solve for x. Either way, we need to be able to get that phase shift so that we know where to start graphing on the x-axis. Okay, so one last example, but be careful. I have said here that the phase shift is not pi over 2. It is also not negative pi over 2, so just be careful with that. And the reason is because we've got this 2x here where the 2 is not factored out. So we'll get to the phase shift at the end after we go through everything else. First, the amplitude, which is going to be positive 3 with a vertical shift of 1. And so that tells me that I'm going to have my midline at y equals 1. That's where my quote-unquote zeros are going to be located on this particular graph. And then I'm going to find my period. Well, my period is going to be 2 pi divided by b, which is going to be 2, which is going to give me a period of pi. That will help me find my x increment, which will be my period of pi divided by 4, and that won't reduce, so I'll just leave it as pi over 4. And now finally, the phase shift. And again, like I said, you have a choice. You can either factor out b, which in this case is 2, or you can set the parentheses equal to 0 and solve for x. It does not really matter. If you factor out the 2, then this will be x plus pi over 2 divided by 2, which is really just the same thing as saying pi over 2 times 1/2. And so that is going to give you pi over 4. And so therefore, the phase shift is negative pi over 4, because now the 2 is factored out, and so this right here will just tell you what the phase shift is. Again, remember that the plus sign means that you're going to the left. If you set the parentheses equal to 0 and solve, then that's going to say 2x is equal to negative pi over 2. Divide both sides by 2, and so x is going to equal to negative pi over 2 times 1/2, which again will be negative pi over 4. So either way, we know our starting x value is negative pi over 4. Now let's continue doing our y-axis just really fast, because I did forget to do that earlier. I know that my vertical shift of 1 tells me where my midline is going to be, and then my amplitude of 3 tells me that my maximums need to be at 4, so that distance is equal to 3, and then my minimums need to be at negative 2, so that my distance between 1 and my minimums would equal to 3. 1 minus negative 2 is where we get the 3 from. Okay, so now negative pi over 4 is my first x coordinate. I'm going to add my x increment to that to get my next x value, which is pi over 4, and when I add those together, I get 0. If I add another pi over 4, that's going to put me at pi over 4, and then 2 pi over 4, which will reduce to pi over 2, and then finally, our last point, our fifth one, will be 3 pi over 4. And now looking back at the function, we're going to be graphing a positive sine curve, which I know starts at a quote-unquote 0, but it's not a 0 in this case. It's actually up at positive 1. So at negative pi over 4, which is my first x value, I'm going to put a point right there on my midline. At 0, I'm going to go up to a max. At pi over 4, I'm going to go back to the midline. At pi over 2, I'm going to have a minimum. And then at 3 pi over 4, back to the midline, so that our graph looks something like this.